All right, quick little video going through the solutions to practice 1.1 square roots. Let's get right after it. So, number one, we got radical 90 over 40. So I can use the rule that says I can split that up into two separate radicals. And then from here, I kind of have a couple ways to go. I could try to find perfect squares in both of them. Or a lot of times I try to get a radical on top and bottom that can cancel with each other. For instance, I see that 10 goes into both those numbers. So I could do the square root of 9 times the square root of 10. And that's 90. And I'm going to do the square root of 4 times the square root of 10. And basically, since I have the square root of 10 on top and bottom, they divide out and cancel each other. And then I just have the square root of 9 over the square root of 4, which is 3 halves. Number 2, negative radical 320. Well, the negative is outside, so we'll worry about that later. Let's try to figure out 320. And I'm going to use the prime factorization method on this one. So I'm going to just start breaking 320 down any way I can. I'm going to use 32 and 10. You could start however you want, it doesn't matter. And 8 times 4 is 32. And I'm just going to keep going until I get a number that cannot be broken down any further. It's a prime. And so I have a 2 and a 2. And then 10 is 2 and a 5. So everything is broken down into prime numbers. Now, here's what I'm going to do. I am going to gather up my pairs. Every pair of 2's, or pair of anything, a pair of 2's, you count it once. Put it on the outside. A pair of 2's, you count it once. A pair of 2's, you count it once. And then 5 is a loner. It's all by himself. So the loner is going to go inside the radical. And now all the numbers on the outside get multiplied together. And this ends up being 8 square root of 5. And then now the negative sign can jump down. Don't forget that part. And you get an answer of negative 8 radical 5. I know Miss Mahaney likes to use the analogy of like clothes in a dryer, socks in a dryer. So you grab a pair of socks, you pull them out, pair of socks, you pull them out, pair of socks, you pull them out. And you got that one loner sock that stays in. So that's just another way to think about it. Number 3, I can't really break down that radical 5, but I am not allowed to have a radical in the bottom of a fraction. So I need to rationalize the denominator. So in the notes, we basically took that number and we multiply it over itself. Because the square root of 5 times the square root of 5 is just 5. It's actually, there's a medium step, the square root of 25, but it just turns out to be 5. And on the top, I just have to smash these together. 6 times radical 5 is just 6 radical 5. Then the last thing I want to look for is to see if I could reduce this 6/5, but I can't. So we are simplified. We are done. All right, moving right down to the next batch here. So I have negative 9 radical 80 over radical 82. So I'm going to not mess with the negative 9 yet. Well, I see both those numbers. I know 8 goes into both those numbers. So I'm going to try to do a radical 8 and a radical 10. And on the bottom, I'm going to do a radical 8 and a radical 4. Lots of ways to do this problem. This is just how I like to start. So I can cancel out some radicals and have smaller numbers. And then I also see on the bottom there, the square root of 4 is just 2. So now on the top, I have negative 9 radical 10 all over 2. I can't reduce 9 over 2, so that stays there. Radical 10, there's no sense in breaking it down because the only thing I could get would be radical 5 and radical 2. Neither of those are perfect squares, so I know that I'm good to go. I'm simplified. Number 5, I see a subtraction symbol in there. So we have 2 radicals subtracted from each other. Luckily, they're like terms. I have a radical 3 and a radical 3. So 7 radical 3's take away 12 radical 3's would be a negative 5 radical 3. And on the bottom, I have radical 108. If I wanted to, I could see if maybe 3 goes into 108. 3 does. 3 goes in there 36 times. So radical 3 times radical 36. And I wanted to know if 3 went in there because I wanted to cancel out those radicals. And now I can just simplify because the square root of 36 is just 6. And there we go. When you enter this in teacher made, you could do negative and then hit the fraction key and punch it in that way, or some people put it up here. I may not have put both ways on the answer key, but just know that you're correct regardless of which way that you did it. All right, number 6, Carly's building a patio with large square tiles. So why don't I just go ahead and draw one of those large square tiles. So here's the tile. It's a square. And the square has an area equal to 6.25. So if I want to find the side length dimension, I'm going to do the square root of 6.25, which comes out to be just 2.5. So these are the type of tiles she's working with. And we're talking about feet. So these are pretty big tiles, 2.5 feet. Should be what, 30 inches? She uses 16 of those tiles to make a square patio. So she uses 16 tiles to make a square. So that would be basically a 4x4 square. And every one of these tiles has a dimension of 2.5. So kind of combining these together, 2.5 times 4, that's 10 across this side, 10, 10, and 10. So we have a perimeter of 40. All right, moving on down. Figure below is made from squares. Given the area of the entire figure is 2070, find the perimeter to the nearest tenth. So these are kind of my goals. I think I'm going to have to kind of do it in this order. I'm going to have to, number 1, find the area of each little square. Okay. Step 2, take the square root of the area to find the side length. And then step 3, use that to find the perimeter of this shape. So step 1, how much is the area of each square? Where if the entire figure is 2070, I need to divide that by, there are 1, 2, 3, 4, 5, 6, 7, 8. There are 9 squares there. So divide it by 9. That goes in there 230. So I know the entire area is 230 of each square. So like this little square right here has an area of 230. Well, then I need to take the square root of that area, which is going to give me a decimal, I believe. So let me grab a calculator here. And I'm going to do the square root of 230. And I get 15.16. And it keeps on going. 575. And I'm not going to round it just yet. I'm actually just going to leave that number in my calculator because I know I'm going to have, let's do the perimeter. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's 16 sides for the perimeter. So I basically need to do 16 times that number that's already sitting in my calculator. So times 16. I end up getting 242.65. We'll call it 242.7 if we round to the nearest tenth. All right. Number 8, an acre of land is 43,560 square feet. So let's kind of just draw that. I have an acre of land. And if its area is 43,560, if I take the square root of that, square root of 43,560, I should get 208.7 as the dimension. So when it says what is the frontage or the width of your property, it's 208.7 feet. So if you buy a 1 acre parcel of land and it's a square, those are your dimensions all the way around. Now most homes in the Meadowbrook neighborhood have a lot size of 0.17 acres. So what is the square footage of these lots? So if a Meadowbrook lot is 0.17 of an acre, I can just multiply that by a whole acre. And 0.17 times 3,560. Gives me a grand total of roughly 7405. You also could set up a proportion. You could say 1 acre is 43560 feet. So 0.17 acres is how many feet? And if you wanted to, you could cross multiply. And 1 times x is just x, so that gives you your answer. And you're basically just doing what I did to the right there. Now we look at a couple SAT type problems that involve square roots where they try to trip you up a little bit. So the first one here says, if a is 5 radical 2, then 2 times a is radical 2x. Well, basically, we're just doubling it. We're just timesing it by 2. So 2a's really is going to come out to be 10 radical 2. Because when I do 5 radical 2 doubled, I get 10 radical 2. But they tell me that has to be equal to radical 2 times x. And radical 2 times x could also just be written as radical 2 times radical x. And it looks like I have a radical 2 on both sides, so that can go away. So basically 10 equals the square root of what? And the algebra way to solve this is you just square both sides to get rid of a square root, and you find out the x must be 100. Number 10, we have an equation there. I see some perfect squares, so let's just cancel those out. So that's 3. That's 8. So I have something plus 3 equals 8. Well, I know 5 plus 3 equals 8. Now, 5 isn't the answer, though, because I got to somehow make the square root of x come out to be 5. So again, just square both sides to get rid of that square root, and you get x equals 25. They want to trick you.